Next, we'll look at calculating the present value for an investment, meaning how much money would we need to invest today to hit a specific future value or future goal. So in example 4, we want to hit a future value of $40,000 in an account with an annual interest rate of 4% and 23 years for that investment to grow. The formula that we'll use for this will be capital P of capital F, comma R, comma T, comma N is equal to capital F divided by the expression 1 plus R over N, all of that raised to the N times T power. And we'll look at this with interest being compounded annually, semi-annually, etc. I already have this formula plugged into Desmos, so we can calculate capital P of our future value of $40,000 with an interest rate of 0.04, a time of T equals 23 years, and we'll start off with a compounding period, or start off with one compounding period representing interest being compounded annually. And we see that what we would need to deposit today would be $6,229, and we'll round that up to 6 cents, since we always round that idea of present value up to make sure that we have enough, because if we rounded down to 5 cents, we would fall a little bit short of our goal. And then we can change that value for N to see what that present value would be if interest was being compounded semi-annually, quarterly, monthly, or daily. And once we get to compounded daily, we see that that present value, that single deposit we would need to make today, would be $15,941.57. Filling out our table here, the values that we would have seen there when interest was compounded annually would be a present value of $6,229.06. For semi-annually, we would get $16,086.15. When interest was compounded quarterly, we would get $16,013.78. When interest is compounded monthly, we get $15,965.17. And when interest is compounded daily, we get $15,941.57. Keep in mind that for each of those values, we rounded up to make sure that the initial deposit is enough to hit at a minimum that future value. And the pattern that we see here is that going from when our interest was compounded annually to daily, that present value actually decreased by $287.49. The reason for that being more compounding periods grows our investment faster, so we can invest a smaller amount upfront and still grow to hit that future value, because the increased number of compounding periods grows that investment faster by calculating and adding that interest to our principal more frequently.